Good evening, everybody. It's Friday night here, my friends. And I'm back and ready to jump in to some more game dev stuff, or trying to learn some game dev stuff. Welcome on in, everybody. Welcome. I don't know what some kind of alert popped up, and I don't know what the hell it was. It's not even showing up. The notification's not even showing up now. No idea. No clue whatsoever. But it does look like we're live and everything. Okay. So, cool. And stuff is working. From what I can tell, anyway. But yeah, welcome everybody. Hope everyone's doing well. So we had some good success last week with our game dev stuff, where I was able to get the arc ball stuff to work. At least it looks like it anyway. So that's some good stuff. I mean, it's not the prettiest thing right now, and it's only, like, it's very, all this code is very like beginner. Sorry, hang on a second. Is very beginner stuff right now. Like, it's just focused on just the one thing that we're trying to do. I do intend on making it far more generic, as it were. Make it so that these things are able to handle more than just one, 3D model and all that stuff. But right now, it's the important part is to get it to where I can start to understand some of what's going on. I don't understand all of it. A lot of it's math that I probably never will understand. But I can at least kind of, it's really just me building up repetitions on it, right? Like trying to get the experience I need to really see what's happening here. The other thing is too, I do want to maybe start digging into the Vulkan stuff as well, because we've got OpenGL stuff here. The problem is I don't know if there's any good. I think one of the things I want to try to find out tonight is if there's any good documentation or tutorial or something out there for it. So that's going to be one of the things I want to take a look at. First and foremost, though, let's just make sure. I'm pretty sure everything should be still working here. So let's just do a new build, clean build, and just make sure to remember exactly where we left off. So this should still be working okay. It certainly is, although it's stutter stepping a bit, but I don't know if that's just because of might have just been something going on at the time. All right, not too shabby, not too shabby. It's working for the most part. Okay. So there's one other thing though. One of the things about this mesh here is that there is an emissive texture map, albedo, which I think is what we're using, and then the emissive one. And that has a file, yeah. So this emissive textures file. So I would like to see if I can integrate that with everything else. I assume it kind of goes the same way that everything else goes, but let's see here. So I gotta reacquaint myself here. So we've got, here's our path to our texture, right? And so I'm gonna say public static final emissive texture path. Alright, and I'm gonna grab this and what was the name of it? Actually, copy location. Will that work? Yes, it will. Cool. Okay, so that's our emissive texture. So how would I... incorporate an emissive texture? Let's see here. Let's see if I can grab some sort of keywords here. Weird. It was. Sorry, I don't know what that was. Napkin here. There we go. Oh, I think it was just I must have spilled a little bit of coffee on the pad that my keyboard sits on. That's what's going on there. It's like, what is why is that wet there? Okay, so I've got, what do I have here? I want to go to this. Alright, so all that kind of worked out. The model loading also includes an emissive texture file. How do I incorporate that into my program? There we go. No, I am not Swedish system. It said so on Twitch. It shouldn't. It shouldn't at all. Channels in Swedish? Really? No, I should be English. Yeah, no, my tag is English. I don't know, maybe that's a problem with Twitch itself. Unless Twitch doesn't know the difference between languages, which is entirely possible. Yeah, that's probably what it is. Welcome on in. How you doing? Why do I use Eclipse instead of IntelliJ? I just kind of prefer. I kind of prefer Eclipse. Eclipse is something I've used for a long time, and I prefer the interface of Eclipse. IntelliJ has a lot more features and a lot more good stuff in it, and I use that for my day job. But it's very the interface is very busy, and the code editor is very busy. Like, it's got tons of, like, tags and stuff that it tags onto lines of code and everything, and it just kind of gets annoying to look at things. Plus, it doesn't, for whatever reason, I have not been able to find a dark mode that is as good as nice as the Eclipse dark mode. Like, they have a bunch of them out there that have, a bunch of ones that you can download that are supposedly the Eclipse dark mode stuff, but none of them, like, have the right blend of colors. And there's always, like, one or two colors that are just, like, almost impossible to pick out when you're looking through the code. So that's really the reason. It's just that the interface is, like, everything just in Eclipse just kind of gets out of your way because you got perspectives. Like, I don't need the debugging console open constantly and all that stuff. And I know in IntelliJ you can collapse a lot of that stuff, but it just it still takes up room and space on the screen when all you really want to do is, like, sit there and write code. You know what I mean? And so that's kind of why I do Eclipse for, like, my personal projects. Eclipse is a pain in the ass in a lot of other ways, particularly with the build integrations and stuff like that. But it's I've used it for so long that I know some of the pain points, and so I kind of compensate for them here and there. It's just it's just sort of nicer. I feel like I can read the code a lot easier in Eclipse. It's harder to follow stuff. It's harder to follow code around. It's harder to find back references like you can in IntelliJ. Like, you can just click on this has 4 references and it takes you to where it's at. But it's also, in my opinion, a lot easier to search the code base. Because in IntelliJ, you can search for phrases and stuff, but it just gives you this messy window with tons of tabs, and it never quite gives you exactly what you're looking for. And it'll reduce your number of results to, like, 50 or so, and it's just... I end up a lot of times, when I'm doing work stuff, I end up just, like, using astrogrep or something, because the search tools in IntelliJ just are just annoying sometimes to me. But it's, whereas here I can just, I can do, just an edit and, not an edit, search file and just type in anything and pretty much get exactly what I'm looking for, get all the references I'm looking for without too much of a mess or craziness, and stuff like that. So, yeah, things like that. It's not a huge... IntelliJ is a lot nicer to work with, in the grand scheme of things. but Eclipse is just kind of cleaner on the brain. Do I know any other languages than Java? Yeah, so professionally I've done mostly Java, but I did do some Ruby on Rails professionally. Um, and a little bit when I first started out in my career, I was doing Visual Basic for a little while. And then as far as like in college, I was doing C. Didn't do a whole lot of C++ because I didn't really have a need for it. It was just college projects, but I understood enough of it. And on my own, I've done, C development. I've done, obviously, JavaScript stuff. I've done assembly language a little bit, and some Pascal way back in the day when I was in high school, just learning stuff. Turbo Pascal, to be fair there. And then recently, about, I guess it's 2 years ago now, I contributed some code to a streaming site that no longer exists called Glimish, and that was in Elixir. So I had to learn that well enough. I mean, there's still parts of that I still struggle with, but I know it well enough now, and to sort of muddle my way in through it. Yeah, no, I got a couple things. Obviously, database stuff, SQL, and all that I do all the time. Trying to learn C. I've experience in programming, but C seems kind of strange. How'd you learn it? I fell into it. Essentially, I had a book. Let me see if I can pull it up here. Teach yourself game programming in 21 days. There we go. So I had this book. I bought this book when I was a kid. This was back in high school when I got my first computer. And it was Teach Yourself Game Programming in 21 Days. It's by Andre Lemothe, if that's how you pronounce it. And I did not know anything that I was getting into. I was like, I have no idea what I've gotten myself into. And basically inside that book, it not only teaches you about like how DOS worked, but also how the mouse and keyboard worked and all that stuff. And it had a lot of game samples on a disc, and it also came with Visual C++ 1.0 on disc. And so I used that to just try to learn basic C concepts and also some macro assembler, because again, this was game development stuff for DOS, so the Windows wasn't really in the picture there. And I just kind of got the ball rolling. That though was, like I said, C++. That was like it was Visual C++ 1.0, but I was doing C only, and that was like old school C. We're talking 95, 94, probably at that, so the best way, basically the way I learned it there was to just look at the examples in the book and just kind of start emulating those. And then I went online and just kind of tried to find whatever information I could here and there about just like you know, how does this work? How does that work? I didn't get any in college. I did get a little bit of development um, information, like training, but it wasn't. I don't think they used C. I think they just kind of did pseudocode mostly. So by the time I got into college, I already kind of knew how to write in C. So there wasn't a whole lot that was foreign at that point. Should you go into YouTube and follow along and try to change the project into your own? That's one way to do it. YouTube is might be a little bit harder to really get into, but there's certainly some good YouTube videos out there, I would imagine, that would teach you that stuff. The best thing you could probably do there is find a series of YouTube videos where they give you a link to their GitHub, and as you have the video up, also have the GitHub up, and like look at instead of looking at the code on the video, look at the code in the GitHub and just kind of use that as a way to peruse what's going on, because then you can really, it's a little bit easier to see it when full screen rather than trying to see it in highly edited videos. You find books hard because of your aphantasia. Yeah, I can imagine. It's yeah. I don't. It's going to be. It's. I wonder though if. You'll have trouble with the programming books or not, because a lot of programming books is just like snippets of code. I mean, there are paragraphs of text and stuff, but a lot of them just have snippets of code and stuff. So you may not have as much trouble with them, but that kind of, not having that, I don't know for sure if that's the case or not. That's why I say also it's good to, even if you don't read the book, to go to like a textbook's GitHub and look through the examples in their GitHub and stuff. Manning books. So Manning Publications. This has a lot of good technology and programming books and stuff. And they're usually pretty clean text in them and stuff like that. You can also get ebook and PDFs and stuff. But this has, let's see. Let's see. I guess you gotta do C++. Yeah, C++ learn by example. I think, isn't there a C learn by example? Okay. So we got Haskell by example, C++ by example. As far as they don't have just plain old C anymore. I mean, C++, any C++ book is going to cover C, because it's just built on top of it. So, yeah. I also tried getting a tutor, but there are like 10 courses and it's only for Uni. Yeah. If I'm not mistaken, doesn't MIT courseware program? So, looks like they're using Python, which, to be honest, I mean, it depends on what you want to do, what language you want to learn. But if you're just trying to learn how to develop, it really doesn't necessarily matter what language you pick. If your goal is to just learn how to code, so you don't have to limit yourself to C if you don't want. You could learn Python or anything like that. But MIT, Massachusetts Institute of Technology, has this whole open courseware thing where you can actually, I think these are all free if I'm not mistaken. You can just go and like download like materials, their lecture materials and all that stuff. And this might be a little bit. They have videos too. I did not know that. But this might actually help a bit as well, and it's all free. So, you know, this is a good one. I mean, they're college level courses, but honestly, you know, they're not going to. Don't let that put you off. They're still introductory courses. You know, Python, Java, and some JS. Okay. So you're just trying to learn C based on what you already know. I can tell you, just like, if you've already got Python and Java and even JavaScript under your belt, the hardest part of C is that it's functional instead of object oriented. So, because I started out functional, object oriented stuff was a little bit more difficult for me. Going back the other way, I'm not sure. But it's essentially, you just have to drop all your thoughts about object orientation and you're just writing code that's, using global variables or using structures and all that stuff. And you can kind of think of structures as like an object, kind of, but they don't operate the same way. That kind of thing. And though I am curious, is there do you have a particular reason for C versus C++? Because C++ would be a lot closer to what you already know in Java. Is it just that you just want to learn C? Nothing wrong with that. Let me see. Programming in C. Do they have something? There you go. Practical programming in C. Introduction to C and C++. Here you go. So that is Core C, compilation pipeline, C memory management, control structures, variables, scope. Oh, here you go. They got good old factorial, lab exercises, all this stuff. So this is I'll put the. Let me put the. Where am I at here? This is, when was this done? no idea. It looks like it's saying 2013, which is kind of old, but not that. Oh yeah, January 2013. I mean, it's old, but it's not that bad. Um, you saw someone said that C++ is abstract, and if I learn C, it'll be easier to learn C++. Well, yes, but because C++ just builds on C. But if you already know Java, Java basically is Java was built because the designer of Java felt C++ was a little too complicated, believe it or not. And then he went and made a relatively complicated predecessor to it. So a lot of the concepts in Java already exist in some fashion in C++, and then some. Like C++ lets you overload like operators and stuff like that. And overload operators, and like you have to do your memory management. There's no virtual machine. There's no garbage collector or any of that stuff. So you have to do memory management yourself, which I think is probably the harder thing that you have to learn there. Oh, you lost a lot of your Java knowledge. Okay, fair enough. I think probably, it's not a bad idea to start with C, because one of the things that they'll probably teach you in it is pointers and memory management, because those are like two of the most important concepts, and both of those affect how you work with C++ fundamentally. So, in fact, they have a whole lecture on memory management and stuff here. So, yeah. You have some old Swing projects from 5 or 6 years ago on your GitHub. Yeah. There you go. I just recently was doing stuff in Swing again. It's been a while. But I have one of the other projects I stream. I'm working on a streamer bot, and it's got a little Swing interface for starting up the server and all that stuff. So yeah, it's been a while. It's been a while on that stuff. But I mean, that's what I did in college. I did a Swing app. I learned Java in college. They actually had a Java class, which was one of the few like language-based classes they actually had, and that was nice. But yeah, this might be a good place to start. Like, if nothing else, to get a jumping off point for other things. I mean, it's probably not going to be very they're not, I mean, they have a PDF here and stuff you can look at and stuff like that. This one doesn't seem like it has any videos, but there's other videos and stuff on here. So there's that. But yeah, I don't know. I'm so rusty and out of shape when it comes to C. Like, I haven't used it since college, which was about, we're talking 2000, 2001. So it's been a long time since I've done anything with C. So I am very, very rusty with that when it comes to that. So I've been trying to avoid it, honestly, because I'm so rusty with it. But I say that, and then I'm with a lot of this game dev stuff, I'm having to look at C to try to figure out like this. Like here's some straight up C for you. And looking at this stuff and trying to translate it over to Java and whatnot. So, but yeah. You started with Minecraft plugin development in Java and you started to make Minecraft for fun, make cheats. Yeah. I mean, I think Minecraft probably got a lot of people to try out Java in some capacity. I mean, even I thought about, like, I had downloaded Forge at some point and was going to dig into it and try to make mods for Minecraft and whatnot, but I decided it was, I wasn't that, I didn't have any ideas that weren't already implemented by someone else. The ideas for plugins that I had already existed, so it wasn't really a whole lot of reason for me to run with them. Where's my... Yeah, here we go. And, well, yeah. I was going to say, if you're on GitHub, I think GitHub Copilot, they just released for everybody now. It's free for everybody, if I'm not mistaken. So it doesn't hurt from time to time just to ask specific questions there, just to get keywords that you can then use to Google search for more information too. So could create bypasses for cheats. That has a lot of math, which is fun. Up to anti-cheat developers. Yeah. It's I think what's funny is I think Minecraft did a lot for Java game dev, but it also hurt it too in a lot of ways, because people would get really upset and really frustrated with the Java version of Minecraft, because they're trying to load 200 mods in, and stuff's not working, or it's taking up all this memory and all that stuff, and then they think, oh well, Java is terrible because of all this and that, and it's like, well, it's certainly not it's certainly not a terrific language, but it's not really the language that's causing a lot of those problems. It's the programmer. Java's great. I love ElasticDB. Yeah, I have not actually I have not dug into ElasticDB yet. I do suspect at some point I might have to dig into it. But I've been able to sort of avoid some of that. Because the funny thing is, like, even though I am a full stack developer, I tend to spend most of my time near the front end of that stack, where it's like, just the web page down to the controller, and then some database stuff. It's rare for me to work on like service layer things like ElasticDB and microservices and things like that. It's very rare. I do have written some web services, but again, it's much rarer than just the typical model view controller stuff. So at least for me anyway. So it'll be interesting to. I have a feeling it's going to be probably have more service architecture stuff soon, I suspect, rather than the monolithic stuff that we're doing now. But I don't know. I still see a lot of value in the monolith. You know, the one thing that browsers are still really good at, it's taking HTML and rendering it. You know, and I think throwing a whole bunch of JavaScript at a browser is just asking for problems later on. You know, it has its uses, but it's a tool like everything else, you know. You have over 5 billion rows, analyze DB and get instant results from a search. That's, yeah, I mean, that's the power of like a big data database like that. And I've only worked at one company that, well, I mean, technically the company I'm working at now does have like a big data database, but I've only been close to one when I worked for a company that did analytics, and click-through analytics and stuff like that, where they would basically they were writing a click tracking and all that stuff for marketers, trying to attribute clicks to particular, trying to figure out how users got to their site, figure out how good their marketing actually is, and whether the marketing led to click-throughs and all that stuff. And so they had a what did they have? They had I'm trying to think of the name of it. The name escapes me at the moment. It wasn't an Elastic DB, and it wasn't like a MongoDB. I think Mongo was after that. It was more of a I forget the name of it now, but it was definitely one of those like in memory, push a whole lot of data through the system, systems, and I cannot for the life of me think of it. No, it wasn't MariaDB either. I can't think of the name of it now. I don't even remember what it started with. The letters it started with. That's the problem. It's just kind of left my brain. It's been like 15 years or something. But yeah, no, and that code was already written by the time I got to the company, and thankfully it all just plain worked and I didn't have to do anything with it. I wanted to learn it, but it was like a huge paradigm shift from what I was used to. It was like, and everything was working and it was a critical component, and I'm like, I don't know if I want to throw myself that far into the deep end. I was a little bit scared. Excel, yeah. No, you joke, but it was we did have an Excel plugin that was custom written in VBA, just because some of our customers, despite the fact that we had a custom UI that we did on top of, Google Analytics and all that stuff, they just wanted all their stuff in a spreadsheet. And so the spreadsheet had Visual Basic for Applications embedded in it, and it would call web services on our side to populate itself. And it was just, they had put so much effort and work into a UI, and the UI was really good. It was Flex, so it was Flash based, but it worked really well, and it was nice. It was nice on the eyes. It fast, and most of the customers just wanted that freaking VBA plugin for Excel. And what was worse was they contracted someone out to do it. And so no one in the company, no one who worked full time for the company had the code or had access to the code. So every time there was a bug or something needed to be changed, they had to go pay some contractor, some consultant, a whole bunch of money to go off and do it. And then there was no guarantee they would get it done, anytime today. You know? There was no guarantee of how long it would take them to do it or whether they would ever get it done fully. That was a thing. Yeah, it was not a bright, shining moment, but it was a decision that was made well before I had joined that company, and so it was just kind of the way it was. Honestly, when I joined that company, like, I was only there for, I think, I want to say it was just over a year, like maybe a year and 4 months or something. Because the company was already kind of on the downswing. It was like the clients were unhappy, the money wasn't coming in, the competitors were just eating their lunch, and then they just kind of decided, okay, we're just going to sell the company to some other company. And they did. And then that other company who bought us really had nothing that they wanted to do with us. Like, it was one of those things where they had the same venture capital funding that we had. And so the VCs just do this thing where if a company's underperforming, they'll just sell it amongst themselves to try. They'll just consolidate and try to get as much money out of it as they can in the process. And that's all they did. They just kind of folded us into another company that really had no use for us or no vision and nothing for us to do. They were just kind of like, you gotta do all kinds of stuff, but we're not going to tell you what it is. You just have to figure it out on your own. And so all the people in the company just started leaving, and I was like, well, I guess I gotta go. I don't want to be the last one out hitting the lights. So so I did, and that was during the period of time where I had several different companies in a row that were in a similar situation where I joined them just as they were on the downswing, and they got bought out, and then the company buying them decided that they wanted to change everything enough to make everybody want to leave, and that was that. But okay, cool. Well, thanks for dropping by, System, and I hope you can find the information you're looking for as far as C is concerned, and hope you have good luck with it and all that stuff. So cool. Thanks for stopping by. I appreciate it. Let's see. So I want to. Did I? Oh, I did do it. Oh, here we go. Model loading. To incorporate emissive textures into your OpenGL program, you need to load the emissive texture, modify your shaders to handle emissive mapping, update your rendering code to bind emissive texture. Oh, it stopped. Please continue. think it's upset here. Please repeat your answer. I think it's very upset. All right, let's do new conversation. Can I see, it loses its context when you do that, which is kind of annoying. Let's see what happens here. Hey, Painson. Yep, I'm trying to learn or continue to learn some game dev if I can. Trying anyway. We'll see. How you doing? Can I let's do this. Can I do, why is it not, why is it like losing its context? That's going on here. Ask about the repository. I'm doing pretty good. I have no complaints. How do I change my code to incorporate loading emissive textures from a separate PNG file or the model loading. Oh, you know what though? This is gonna use. That's using GPT. I don't want to use GPT. GPT sucks. Do I incorporate loading emissive textures from a separate PNG file or the model I'm currently loading in my project. I think Claude is having a problem tonight. Potentially is having a problem tonight. Yeah, Claude doesn't want to talk to me tonight. It looks like. All right. Huh. What do you mean by emissive textures? Well, that's a good question. Because this is the model that I'm loading. And this is how they have like a model thing here, model inspector here. And I've got the model loading and I'm able to spin it around and stuff. But they say they have 3 texture maps, although really only 2. One of them is emissive. And when I look at the files that they gave me, so we got the ship textures file, and then we got an emissive texture file. right? Which doesn't have much in it, but it's not a big, complicated model either. So I'm loading the main file here. I'll run this. All right, so I'm loading the main textures and stuff. And this seems to be correct. So my question is, there's this second file here with the emissive thing. How do I incorporate that into the model itself? Or have I mean, I'm not loading this file yet, so I don't think I've incorporated it yet. I might be loading the data for it, but just not using it. And that's what I'm trying to figure out. Do I need more shaders for it? Like, do I do something else? I don't see. I just don't know where to start. And so I'm trying to, like, I've been using the AI, like the Copilot stuff on GitHub, just to kind of give me a starting run at things, so I can know what to search for. Because what I'm finding is I'm having a lot of trouble finding stuff in Google and whatnot, that gives me, I mean, I'm getting a lot of stuff for C language, but I'm not necessarily getting anything for Java. And I'm trying to see if this will help me, like, find Java stuff. Doesn't seem to be wanting to help me even with that, though. Maybe I can say, please explain emissive textures in OpenGL. They're used to simulate objects that emit light. These textures define areas of the surface that should appear to glow independent of external lighting. Emissive textures are commonly used in rendering to create effects like glowing lights, screens, or other self-illuminated surfaces. Okay, so that's probably for the engines of the ship. All right. Oh, here we go. Example fragment shader code integrating emissive textures. Emissive texture, texture coordinates. Huh. I think this has to do with PBR, but I'm not sure. Can you give me a link of the model you're using? Sure. Sure. Make it my cursor over there. Boom, 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 boom. So it sounds like it's just to make the engines glow, which I can see on this model the engines are glowing that lighter blue color, which is cool. I mean, I want to integrate that if I can, but it looks like it's just another shader if I'm reading that correctly, which makes sense to me. I don't know if I have to do a separate shader or if I can use the existing one. So let me see. Given my current project, how would I incorporate loading, rendering, emissive? Yeah, this has to do with PBR. Okay. So I don't know. I have no idea what a lot of these things are. So I can look up some things. So this is doing load the emissive texture. Yeah, okay. GL bind texture. GL generate bitmap. Yeah. Set up shaders to handle emissive textures. Modify your fragment shader to include logic for handling emissive textures. Here's an example of a fragment shader. Okay. Integrate it into your rendering code. Find the emissive texture and pass it to the shader. Okay. I mean, that makes sense. So, okay, so they're binding the emissive texture to texture area 1. Okay. So it sounds like, if I look at my code here, so number 1, I gotta load that file, but we'll get to that in a second. What I need to do, so here's render, projection matrix, set uniform. Where do I load the texture? Here we go. GL active texture. Texture bind. That's texture path. Okay. Okay. And so, theoretically, I do, let's see, texture, emissive texture. Texture path, texture, no. GL 46, GL active texture, GL 46, GL. Texture 1. Theoretically. You're not very familiar with the PBR stuff, but apparently it is a texture that specifies regions of the model that can emit light. Okay. Okay. So texture, I have what? Path, load texture. I assume just doing the load texture is all I need here. Probably. Alright, map, bind texture. Yeah, I'm gonna assume that all that stays the same. And then okay, so that is, whoops, where am I at here? Okay, so I bind that to texture 1. Do I reference this again? I don't think I do. See something here. I do have a, yeah, I do have a delete textures and stuff. I think that'll just handle itself. So I have that, and I have the emissive texture path. So then the fragment shader. So Ronald.frag here. Ugh, this looks bad in Eclipse. I don't like that. I don't like how it colors that, but whatever. We'll deal with it. So you've got out vector 4 fragment color texture. Yeah, okay. Material. It might be better just ignore it. Well, I mean, I've got. I would like to learn, if I can, learn how it works. You know, I figured now is a good time to, because, you know, I'm not. I only have the one model that I'm loading, and I want to just exhaust some of that pathway. I don't know why this has added all these lines in here. It drives me nuts. And then I can look at, you know, I have other things to look at too. It's not like this is the only thing, but I just figured I'd dip my toe in it. And if it's harder than it looks, then it's harder than it looks. At least I know. So what's it doing? Fragment color. Base color, emissive color. Oh, I see. Emissive. Right. Vector 4. Base color. Sampler material. So, oh, I see. Because it's adding it to the existing texture. Ah, I see. I see. Is it like a shader? I think you would need to implement a full PBR renderer to make that work. Oh, okay. I mean, I have so little code now that if I have to implement that, then maybe that's a good thing. It really depends. It depends on how. Because here's the thing, I like to get this as much into this as I can early on, because I'm also trying to look at Vulkan rendering as well. So I've got like the OpenGL thing, and now I also want to look at the Vulkan rendering. I want to take the engine I've done for OpenGL and see how it relates to Vulkan stuff. Because again, my goal is to learn this, not necessarily to. I'm not in any race to get anything done. So I mean, if it takes a little bit to do it, then it takes a little bit to do it. I'm not in any particular hurry. Integrate emissive texture. So how would you do that? Emissive texture. So it's just adding a uniform called emissive texture. Okay. Sure. But again, this is ChatGPT 4.0, which has been known to throw me way the hell off stuff. So I wonder, LWJGL emissive textures. Glowing object. Definition. Learn OpenGL. Okay, let me see this one. Copy that. Why is that? Why did it copy that? Come on, Twitch. Come on, Twitch. I asked you one easy thing to do, which is just copy the URL, not the whole. Oh, you know what? I know what's going do it that way. There we go. Physical base rendering. Service ladder. This rough surface. Conservation. Reluctance. Intensity. Okay. Bidirectional, reflective, distribution function, specular parts, normal distribution, Fresnel, distribution. Okay. Geometry, sure, material properties. Right. Oh, I see. Okay. Okay. The inclusion. All right, well, that's the math. Where's the actual practical nonsense? Not that the math is not a good thing. It's just math is not my thing. Measures light color, attenuate over its distance. Cosine theta, attenuation, radiance, surface model, okay. Fragment shader implements the previously described PBR models, color, row position, metallic roughness, okay, okay. Normalize. Calculations required for any lighting algorithm. Yeah, I don't even have lighting implemented in there, so this is good, probably. You know, GitHub ChatGPT built-in. Yeah, they call it GitHub Copilot. It has both GPT 4.0, 3.0, and Claude Sonnet. And honestly, Claude Sonnet's been the most helpful out of all of them. So, unfortunately, tonight, for some reason, Claude has been having some brain farts. But, yeah. The thing is, graphics programming is basically all math. Yeah, and I get that. But here's the thing, right? I don't necessarily need to know how the math works. I just need to know the math, right? Like, if someone super smart who came up with all the calculations is like, this is how you do lighting and this is how you do this or this is how you do that, awesome. I could just take that calculation and run with it. I don't need to prove it out. I just need to have something like a baseline, and then I could go tweak it as I feel is necessary. But at the end of the day, you know, it's like I liken it to algebra and stuff. It's just like, you know, you plug in the variables in the equation and you don't worry about how the equation came about. And that's kind of the same way I feel about it. It's like, if this is the correct way to work and it looks decent enough, it's cool by me. You know? Complex mathematics, my nightmare. Yeah, I mean, I was pretty good at linear algebra. I was pretty good at algebra. I was terrible at calculus. You know, and by pretty good, I was like, I can read some of it and I can kind of do it, but I have more of a practical approach to it, which is just, you know, if someone says that this is a decent enough algorithm, then I'm good with that. For more advanced things such as PBR, you probably do. Yeah. I mean, I'm not saying I'm not going to need to dig into some math and stuff, but I'm also not necessarily that. I'm not concerned that I can't find the answer, I guess is what I'm getting at there, you know? It may very well come to a point where I can't find an answer somewhere, and then I'm kind of screwed. But I have a feeling that everything that I want to do probably has an answer somewhere on the internet. And one that I can, like, apply, like one of these, right? And that can at least get me part of the way there, if not all the way there, you know? That's kind of what I'm getting at. It's like, I'm not trying to, if I don't have to flex my math skills, if I can just take something that I can say is reasonably correct, then I'm good with that. You know, I don't need it to be, I'm not doing a physics simulation. Well, I guess technically I am doing a physics simulation, but I'm not going to cry if the physics simulation is not entirely accurate. You know what I mean? HDR rendering. Yeah, like this stuff is like HDR rendering and stuff. That is one thing that I don't understand at all. So that's gonna be a real pain in the butt. Full direct lighting PBR shader. Pass on tone map and gamma correct color refinement shaders output channel. So what are they doing here? So they got material properties. Okay. Light positions, light colors. Normalize. Reflectance. Calculate per light radiance. Numerator, denominator. So it's the dot product of N and V. The normal and the, what's V? The vector? Camp position minus world position. Yeah, I guess it's the, yeah, okay. Specular lighting, radiance, ambient, so color, frame color. Huh. Textured PBR. Extending the system to now accept that service parameters as textures instead of uniform values. Gives us per frame control over surface materials properties. Okay. Texture. I like roughness. Near space. Okay. Huh. Interesting. So I wonder, so the texture then, I have one, so I have two texture files. So I guess that would be this one and then, interesting. But they're just getting the R from it. Huh. So what does that look? Being textured. I wonder if they have the whole, I wonder if they have the full shader listing somewhere. Unless this is just, these are just the things that they added. Yeah, so this is all like lighting stuff. The attenuation. They have, let's see, resources. Lighting textured, here we go. So here's their fragment shader. Huh. Oh, for crying out loud. Freaking bots. I think the bots would learn by now that every time they post in here, I get them banned. Like literally every time. Alright, so report. Bots. Selling viewers. Bots. Block them and ban them. There we go. Done and done. Let's see. So, yeah, where was what they were doing? Yeah, here it is. So, oh, that is literally all they did. I thought they did like, thought they would take like the RGNB, but they're only taking R from them. Interesting. It's so annoying that when you ban them from the chat, they start to DM you. Yeah. I had to turn my DMs off on Twitch altogether because there were two types of DMs I was getting. I was getting DMs from bots that got banned, and I was getting DMs because I turned on the in order to stop the bots, I turned on the you need to have an account older than, what is it, 1 month, in order to chat, or you have to have your phone verification turned on, or your phone number in Twitch. So it was like either or, like you have to have your phone number in Twitch, or you have to be an account that's at least a month old. And I was getting like angry DMs about that. Like, I can't believe you would ban people from chatting in your chat. And it's like, I don't know what you're talking about. Then I had to go back in and I was like, oh yeah, okay, I see what's going on. I will never be back here again, blah, 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 blah. It's like, you could have just, instead of assuming that I am stopping everyone from chatting, you could have just, like, asked me, like, hey, I was trying to chat and I couldn't, like, what's going on? I would have been very happy to say, like, oh, you just, I have this turned on, that's all. It was to stop all the low effort bots, and it did, by and large, work. The amount of bots I was getting now has dropped to maybe 1 or 2 a night, so it certainly helped a bunch there. Okay, so yeah, there's a lot. You're right. You're absolutely right. There's a lot more to going on here with, because I have to integrate ambient lighting and other things, which I haven't done anything with lighting yet. So this is a bigger deal than it initially looks like. Okay, that's fine. Hey, I know something I didn't know, and this is the problem with using AI stuff too, is that it's going to tell you what you want to hear, not what you need to hear, which is, this is a lot bigger than what you have. Okay, so that's fine. That's fine. Let's, what I do want to do though is figure out, like, I want to take what I've got, which is not a lot, but it's I'm loading a file, I'm loading a model, and I'm texturing it, and I'm able to rotate it with the keyboard keys. And I want to see what that looks like in Vulkan here. Just a single model with the same properties. So where do I even start with that is the question. LW JGL Vulkan example. Hello Vulkan.java. Okay. So let's see. Oh man, prepare yourself. I do know that it's a different beast unto itself. What the hell is this? Port it from the GLFW Vulkan test. Oh, they just ported it? Okay. I mean, okay. Fragment shader code, sure. vertex shader code. Sure, we're just gonna use opcodes for our shader code. Text, ASCII text. Who needs ASCII text when you could just use the freaking opcodes? Oh, that's hilarious. You need to precompile the shaders. Yeah, I know, and I want to. Apparently, from what I understand, OpenGL 4.6 that I'm using also can use the same precompiled shader that Vulkan uses, from what I understand. I may or may not be correct in that. That was the other thing I wanted to do, was start to look at precompiling the shaders and stuff too. Yeah, that's right. Spirit. Yep, exactly. So that was the other thing about this, was like, I wanted to try to start the Vulkan stuff now while I don't have while I have the most basic shader I could possibly have, and then I can integrate like the compilation stuff and then see if that works with how I have my OpenGL engine set up and all that stuff. I figured the two kind of tied into one another a little bit there, at least in that regard. Anyway, here, let's go device properties. Okay, so we got our width and height, stencil, depth buffer, I guess, increment, command buffer. Boy, you know what would be really great here? If they put comments in this code, that would be kind of swell. Instead of just plain old porting it without any idea of what the hell you're looking at. That'd be nice. That'd be real nice. Vulkan is like 1,500 lines of code just to render a single trial. Really? I didn't know it was that bad. I mean, there's certainly a lot here, but I'm not seeing a lot more than, at least not yet anyway. Check layers, check. And there's a memory stack thing that they're doing. Buffer, malloc. Huh. So GLFW window hint, create window, set window refresh callback. Set key callback. All that's pretty much the same. Which is kind of, I guess that's fine. I'm surprised that these are the same. But I guess Vulkan doesn't touch the Windows stuff, I guess. It's just doing engine stuff. Nice queue, create info buffer. You have a lot more control over a GPU. Yeah, I figured it was a little bit lower level than the OpenGL stuff. Swap chain, create Windows surface. Okay. Graphics queue, could not find graphics in present queue. Okay. Get device queue. Check. Jesus H Christ, you're not wrong. They're getting into the weeds here. Swap chain buffers. Okay. So instead of GL swap buffers, you gotta do it yourself. You have to deal with sync primitives like semaphores and stuff at the GPU level. Yeah. Yeah, because it's basically, from what I understand, multi-threaded at its heart. Um, Get physical device surface present modes. Although I do wonder if there's a compare textures. Like, so this demo they just poured it, but like, is there not? Is there not a slightly nicer way in LWJGL to do it? Like, I feel like this is, some of the stuff could be abstracted away if they were doing their jobs right. Vulkan Jam. That's the only demo they have for Vulkan? Huh. Let's see this. This is a book written for Vulkan using LWJGL 3. I followed most of it, unless say, despite encountering some nasty bugs in the text. Actually follow. Oh, this might be interesting. Bear debugger, C#, threading, the best dependency management systems, virus handling, and performance. Boy, every forum, you got somebody going, have you heard of our Lord and Savior Rust? Like, I get it, you're very excited for it, but you know, every time another language comes to prominence, it's like, ooh, shiny thing, and everybody's jumping on it. The same thing was true with Ruby, and then everybody jumped on Ruby and found out, wow, this is kind of sucks actually. And they all went back to like C# and everything else. Graphics in Vulkan. Okay. Book code, source code, author. All right, this is. Basic scaffolding code to. Okay, let's see what this is. Introduction. Why Vulkan? Why I select with OpenGL? Capabilities in mind. Concurrency support. It's an API that imposes a lot of responsibility onto the developers, and with great power comes big responsibility. You have to properly control everything from memory allocation to resource management, and to guarantee proper synchronization between your CPU and graphics card. As a result, you'll have a more direct view about the GPU working inner details. Okay. Programming or want to obtain a rapid product, Vulkan is not the most adequate solution for you. Okay. Sure. Verbosity, it's a very explicit API. You'll have to specify every single detail from available features, memory layouts, detailed pipeline execution. It means you have to write a lot of code to manage it all. Okay. Okay. SDK. Raw VM, Tiny Log for logging, Maven, Jomal. Okay. Java version 15. I'm at 21, so suck it. IDE is optional. Okay. Engine. New engine. What is engine? Oh God, I hate this. I hate it so much. I hate it so much. Listen, you want to do star imports for your own actual practical project, knock yourself out. But when you're trying to teach somebody how to do something, you cannot use star imports, because now I gotta figure out what the hell freaking package did all this crap come from. It's like, and I love the fact too, they're like, well, you can use IntelliJ. It's like, great. You know, you can tell IntelliJ to automatically expand these out for you, right? So you don't even have to think about them. You can just say, like, just do this for me. And then the rest of us reading your code can be like, oh, okay, that's where engine came from. Good. All right. Awesome. It's just, oh, that drives me freaking insane. You have to deal with sync. I already read that. Okay. So render game engine modeled by the engine class. This class requires in its constructor name of its application and reference to the class will implement the application logic that's controlled by interface. Cleanup init input. Update. Right. Okay. So engine's their own thing. Cool. Fine. Great. Awesome. Public engine to clean up, run, time. Yeah, I mean, that's basically what I've got already, sort of. Start, stop, run. Clean up. Properties file, engine properties. Oh, they're already loading in properties files. Okay. I mean, I know how to load a properties file, so I'm not worried about that right now. That's cool. Render and scene are just empty shell. Window. GLFW Vulkan is GLFW Vulkan supported. Okay. Actually, this is probably the most important thing right now. I should do this because I have no idea if the computer that I'm working on actually does support Vulkan. If it doesn't, then this is going to be a very short lesson. So let me do this. I mean, I have some of this already in place. So, what do I have here? I've got OpenGL engine, right? So, what GPU do I have? That's a good question. Was it, there's a command. Isn't there like GPU info or something? Oh, cat. Here we go. Oh, do I still have... Oh, I still have that running. That's not good. Intel? That doesn't seem right. That doesn't seem right at all. I mean, it does seem right, but at the same time, it doesn't seem right. GLX info. Here we go. GLX info. Blah blah blah. Do that. Oh, I have, okay, Intel Xe graphics. That makes sense. So this is a Microsoft Surface tablet that I forced Linux to run on. So it's not necessarily geared towards this stuff, but Intel Xe graphics, I would imagine, probably support Vulkan. Yeah, I would imagine it does. But I mean, we'll find out in a second here. Let me get the let me get some of this in here. So I have OpenGL engine. I thought I implemented it. I thought I had an interface for these. I guess I decided to defer that. See that? Okay. Yeah. Where's my main here? Yeah, I guess I deferred doing it in interface. Because honestly, I would know. Honestly, I'll know which one I'm going to be using anyway. I guess I can get rid of this commented out code now. That's a thing. Yeah, you know what? I'm not going to worry about doing an actual interface for the engines, because I figured it'll be different enough that it doesn't really matter. What I am going to do, though, is say package. Okay. And what do they have here? Window title, I don't care. My app logic. Implements iApp logic. What are they using app logic for? Oh, that's their how to call update and all that nonsense. Yeah, screw that. That's just silly. Let's do. What do I have on this guy here? Yeah, I just have a init and stuff. Right. That main loop. Yeah. Yeah, you don't need all that other crap. Because I have OpenGL window. I'm probably gonna have Vulkan window, I imagine. So to new class. Let's make this a little bit more friendly here. There we go. So obviously I need my logger. Go and this is not a great place for model file and stuff, but I'm going to, again, I'm not worried about where things are right now, just trying to learn the stuff and then I can figure it out later. A better place to put them. Okay, so then we've got private. I don't know if these are even going to be correct. But I know some of these I'll need. The long last logic. All right, and then this over here. So I've got logger again. Go. Is long like integer 64 in Java? Yes. Yes, it is. And hold on to that thought for a second. And over here, I'll do 600 by 600. We had there. You always use fixed size types in your code, so that confuses you a bit. Yeah, it's one of the things that I'm trying to kind of rectify here is I've noticed with a lot of the examples and stuff. So obviously, we're calling down to through the Java native interface to the C libraries themselves. And I'm noticing in a lot of instances where I'm having to call like McMalloc calls and stuff like that. And some of that I can understand because under the covers they're using pointer logic, and so you need to malloc the memory for the pointer and stuff. But others I'm just kind of a little bit baffled by because I'm like, you know, I kind of wish that it was a little bit more integrated with the Java, with the Java types and stuff, so that I'm not having to do all that memory allocation and things like that and having to do all the freeze afterwards and all that stuff. I mean, some of it is integrated where they have like an auto closable interface on some stuff that will actually go through and free up the memory for you, which is nice. But yeah, that's one of the weird things about this is that because I'm working with native libraries and stuff, like there's this weird half C, half Java thing going on, and that's always, I think that's going to be a constant pain in the butt. Java doesn't have support for raw pointers. Not that I'm aware of, no. Java can do pointer-like stuff, like it can pass by reference. And in fact, it does pass by reference, but it doesn't have pointers straight up, like necessarily. You like I said, you can do a pass by reference, and that's actually by default, but it's not quite the same as having like a raw pointer that you can just kind of get the memory address of or anything like that. So, because again, we got the garbage collector, and the garbage collector needs to be able to count references in order to know whether or not to clean up parts of memory. And I'm not saying they couldn't put pointers in there, but I could see why they decided against it, because it was like, at least in the initial garbage collection algorithms and stuff, it would make it a lot harder to know if all the references have been, if a piece of memory is no longer being referenced and it can be cleaned up. So I'm not sure how C# handles that, because I have not worked at all in C# really. I mean, I guess I worked kind of a little bit in it, but not enough to get any kind of advanced stuff. Yeah. You think C# has that? Yeah, it very well might. I haven't gotten too deep into C#, honestly, or anything. Like I did a little bit ironically, I did a little bit of C# just to make to use the programmable block in Space Engineers. And that was it. That's the extent of the C# that I've done, was doing programmable blocks in Space Engineers. So I didn't get very deep into it at all. So that's a thing. That's the game that's coming out this month. Space Engineers 2. I was trying to think of, I knew there was something coming out this month that I was waiting for, and it's that. Yeah. Not coming out, but it's early access, I think. All right, so then You remember doing some performance work in C# with raw pointers? Yeah. It's yeah. I like I said, I haven't. Have no idea. Have no clue there. What they're doing over there on that. That is one of those things where the thought has crossed my mind several times that I should probably learn some C#, because as ubiquitous as Java is, and I'll always probably have a job doing Java code, C# is also fairly popular for business applications and stuff. So it's really something I should look at some point. That and technically, I guess Python also is kind of up there, although not as necessarily as popular for like web-based things. But there are definitely companies that have web-based Python applications and stuff. So at some point, maybe I'll dig into some of that stuff. I don't know. It would be interesting though. I need, the problem is I just need, the thing is I'm working on things that I kind of want to just work on, just like projects I want to work on, and I need to find something that I would want to do that would also involve C#. Because most of the things I want to do, I also would just rather do them in like something I use all the time, like Java or something like that. You know? Most of the time you program in C, C++. Yeah, no, I get that. Yeah, it's been ages and ages since I've done any C programming. I never really dug too much into C++ at all. But the C stuff I used to do back in college, and then I never had a professional job doing C. I started out in Visual Basic, and then quickly switched over to Java. So I am as rusty can be when it comes to C, especially modern C. It's like it's not the syntax either. It's just the header files and the libraries. That's where I am just completely out of practice, right? Because when I was doing it, you were just doing everything yourself. There was no like libraries to integrate with, and I mean there were, but you didn't really. They were not easy to come by. And nowadays it's like, I mean that's hard. That's the hard thing about Java even nowadays is like the language itself is not difficult. It's the ecosystem around it. It's learning all the libraries and learning the all the different jar files to bring in and all the and all that stuff. Learning Spring and learning all the web servers and all the idiosyncrasies about the web servers and things. Tomcat and all that. That's kind of the harder part at the end of the day, or at least finding out about Apache Commons and all that stuff. Instead of reinventing the wheel, you just go out there and find some of the Commons, Lang, and all that stuff, and you've got a lot of powerful tools right at your fingertips. So you don't have to think too hard about. Okay, so I'm gonna assume. Let's go back to the example here. So I got that. Oh, I see what they're doing. They're passing main in. So see, I don't really agree with. I know what I understand what they're going for. They're like, yeah, just pass a main class in. But then that means that you're doing stuff in here that you would think would be done in the engine. Right? Like you're doing inits and inputs and all that stuff. And it feels messier doing it that way. I understand why they're doing it. But to me, for some reason in my brain, that's a little bit messier. I'd rather just have the main method be like, all right, handle command line parameters, load up properties files, do all that stuff that's common to whatever engine you're running. And then shove off and transfer everything over to the engine, and then have the engine itself worry about how it's going to handle input and how it's going to do updates and all that. But I think that's more of a me thing than an actual real thing. Scene, render, init. So run and clean up, start, stop. Okay. So he's doing the run and he's saying update. So it's basically following the same pattern that I have for OpenGL, sort of. What do we got here? Load model. Main loop. Okay. So I can basically follow some of these. And actually, I could make an abstract class and have these extend that if the code ends up being very similar. But for right now, let's keep them separate in case I have to do weird stuff. I want to make sure I have something that to reference, so I can look back and forth at, like, this is how I did it this way and this is how I did it in this one. There we go. And let's see. So what did they do over here? Wait, first of all, where did they do the where did they do the Vulkan check at? Oh, they've got it in the window. Got it. If GLFW Vulkan support it. Should that be in the window? Or should we just stop the engine altogether? I feel like I should stop the engine altogether. So that's just GLFW. Let's do that first. Where do I want to go with that? I think that would be important enough to have just in the init. Like, there's no point in doing anything. Oh, I guess they could. Yeah, I guess I could be in the window because I'm initting the window, right? So nothing has really happened yet beyond just creating the window object. GLFW and oh yeah, because we gotta call GLFW init first anyway. Okay. Okay, so then did I put that in here already? I did not. Let's do that. So we'll say if not GLFW init. All right. Okay. Thanks for dropping by. I appreciate it. And thank you for all the help. I also appreciate that. Have a good night. So let's see. Let's say logger error. GLFW failed to init. Okay, and then do you set error callback on this too? They have a set key callback. I wonder if that's I'll set the error callback just in case. I don't know if it applies to Vulkan or not. But I'm going to do that. And then I'm also going to put this if not GLFW Vulkan supported. Does that even exist? That doesn't appear to exist. Oh, it's GLFW Vulkan dot. Okay. GLFW Vulkan. Vulkan supported. There we go. Okay. I wonder if they don't even have the error callback here. I wonder if that's not necessary for this. You know what? I'm just going to comment it out. Whoops, that's not what I want to do. Comment it out for the moment, and we'll see if that's is anything worth anything. Video mode, width and height. Primary monitor. Oh, that's just getting the width and height of the current video mode, right? I assume I can just set it to, yeah, GLFW create window. Yeah. So default window hints, GLFW maximized, false. Yeah, that's correct. So, all right, default window hits. Just what I have there. I guess visible and resizable don't apply? Question mark. All right, configure window. So GLFW, default window hints. GLFW, window hints. GLFW client API and no API. API. Window hint. GLFW maximized false. Okay. All right. Set frame buffer size callback. Oh, that's the other thing I didn't do yet when the other one was doing the frame buffer size callback. So that it resizes appropriately. I'm going to leave that off for right now. Set key callback. Looks like it's the same. So which I do not set the key callback here anyway. I set it elsewhere, so it's fine. Oh, I do get the video mode in order to set the window position. Did I set the window position here? I don't think so, but I imagine they do the same thing with the video mode, right? Yeah. So I'm gonna do this. Like so. The thing is, I haven't created the window yet. I'm sure they've created a window here somewhere, right? Yeah. So with height, Util null, util null. Okay, create the window. Yep. So that's all the same. Which is kind of nice. Okay. What do we do up here? Show window, swap interval. I don't know if that makes any sense. Handler for mouse input. Minimal requirements to use Vulkan are available. Basic ones, the free resources, handling, window sizing, etc. Okay. Mouse input, which I don't handle yet. That's next thing. Okay, let me just see. So where's the code for chapter 1 here? Where's the book samples? Does what I want here. For callback, mouse input. So create the window, but then don't show it. Okay, should close whole events. Oh, interesting. All right. Well, clean up here. Let me pull that over. And what do they have? Free callbacks, destroy window, terminate. Free callbacks, destroy window, terminate. Okay. Feeling more and more like that error callback is needed, at least for GLFW. So I'm going to do that. And uncomment this. And if it doesn't work, it doesn't work. That's just the way it is. Whole events. Whole events, and then yeah, all right. So just copy this directly over. And then this should close signal close. I guess I can copy both of those. Get width, get height, get handle. Do those here. Yeah, they have set should close, right? So all that's pretty much the same. And then where in engine, where do they do... Where do they actually show the window? Am I just going blind here? Am I going blind? Where do they actually show the window? Is it not necessary to call show window? Maybe it's not necessary the way they have it set up here. Makes the specified window visible if it was previously hidden. If the window is already visible or is in full screen mode, the function does nothing. So I guess it's not... Oh, that's why, because they set the window hint visible to false. Ah, right. Okay. All right. So I'm going to copy those over. That's why. That is why. And over here they didn't, so it probably defaults to visible. True. So then I most likely have to do this. Like so. There we go. All right. And then terminate, window should close. Okay, so I think I got everything else there. So then let's input I'm not worried about. Engine properties I'm not worried about. So engine itself. I'm not going to try to render anything yet. I just want to get the window to show up. So let's go to engine here. Let's go to engine here. And we've got the main loop. So I'm not trying... Let's see. Did they put anything in their main loop here? They do. They have... render, which has nothing in it. Okay. Scene has nothing in it. Okay. So we got that stuff there. They don't have like create capabilities or anything in there yet. Yeah, they've got literally nothing. They just have the that. So they don't do like create capabilities or enable thing. Oh, this is where I set the key callback here. Do that. I don't even want to load anything up there yet because I'm not sure what I need to change in those. So I'm just going to do this, and then we're going to do rendering loop. So take these as is. I don't think they need to change, at least not yet anyway. Private void render here. We won't do anything yet there. Oops. And then cleanup wise, just calls AppLogic cleanup, render cleanup, window cleanup. So I'll call window cleanup. As that does. And then our keyboard callbacks, which I'm only going to have escape right now. Oh, actually, I'd keep these in here for now. I'm just going to comment them out because I am going to use them at some point. But right now we're just going to have those effectively not do anything. Okay, window update is the only thing I'm missing right now. So where's that at? Window update, which is GLFW swap buffers, which I don't know if that's, I don't think they have update actually implemented. Comment that out right now. See if they had an update on there. No, I don't think they had anything. It calls AppLogic update, which I think is main. Yeah, to be implemented. Okay. Okay. So I think that's the initial stuff. Update. Are you? Can you still not see update? That's weird. Should exist in there. We do a build. That'll probably. Yeah, there we go. Okay. Any problems? Some warnings. That's it. Okay. Cool. Cool. Let's go to main here, and we'll say so say run open GL and private void run Vulkan. Open GL notes. Info starting program in Vulkan mode. Good engine. Go. All right, good. Okay, let's see what this does, if anything. Okay. It's actually kind of promising. If I hit escape. Okay, that works. I didn't set a color for it to use. I don't know how to do that. Let me see. OpenGL window. Where do I set the initial color? Oh, I think I do that in the update. No. Swap buffers. Engine. Oh, I think, yeah, okay, that's the viewport, probably. That's probably where, yeah, that's where it's getting set. All right, well, we got a window. That's half the problem. Well, it's 1/3 of the problem, at least. Oh, all right. So, the contents. So got that. Mouse input. Not worrying about. All right, next chapter. Wait a minute, what does this say down here? Set callback. Just keep okay. Next chapter, Vulkan instance. Instance first steps. You should have a single Vulkan instance for each application, but the spec allows you to have more. A potential use case for having more than one is if you're using a legacy library that already uses Vulkan, and you do not want that to interfere with your code. Separate instance. We'll start from scratch in this book, and therefore we'll just use a single instance. Integral part of using LWJGL. Former is the memory stack, and the latter is VK info. Most of the Vulkan related code will be placed under a package Vulkan engine graph VK. In this case, we'll create a new class named instance to wrap all the initialization code. Oh, to create a Vulkan instance? I mean, you're only creating a single instance, so why are you bothering with a class just to do that? I mean, I guess they're trying to say, like, well, you know, if you really do want to have multiple instances, here's a class. But I mean, like, you're doing one instance, so just do one instance. Memory stack to share data with native code. Use direct off heap buffers instead of relying on JNI. You can use buffers as C pointers for region of memory. Use the passive initialization to solve this. Comes up with a memory stack, which is basically a direct allocated stack where we can reserve direct memory when we need to exchange short-lived info with native functions. Okay. That helps with information sharing. Let's see if Project Panama could find an easy invocation of native code from Java. Yeah, I was hearing some stuff about Project Panama. For native code stuff. I don't know how far that has gotten. Yeah, I don't know how far along this has come. Java Project Panama. I mean, is this already done? You can find the latest version implemented in JDK 21 as a preview feature. Yes. Okay. So it's there, but it's not. You have to enable a preview. Okay. So, see if accessing foreign memory not managed by JVM. The API enables Java programs called native libraries and process native data without the brittleness and danger of JNI. Okay. Native interrupt 2. Okay. So, assume you're tired of all the abstraction of Java IO API and just want a file. To read a file using traditional IO functions, a standard C alive. Okay. So you're doing a file pointer, fopen, malloc, get the first 1K, up to the first 1K, print it out, close it, and free it. Okay. We can access the required C functions directly with Panama, wrapping the C functions and writing the C program as follows in Java. Okay. File fopen arg0r get s fclose file. Do we implement the wrapper methods? We start with the file fopen. Before we call it, we have to get a hold of its method handle. This looks up the fopen symbol and all the libraries that the current process has loaded. Native linker and symbol lookup. Okay. Just looked up memory. Looked up function is located. Okay, method handle. Invoke exact. So we're doing basically Basically, ooh, sorry. Basically, reflection against native stuff. I mean, more or less. Okay. Except you have to do. Interesting. Except you have to do a lookup for it, which I guess makes sense. Native linker, download, downcall handle. Okay. The buffer, implement the fclose file function to close the file. Fclose, invoke exact file. Okay. JExtract can parse header files, generating method handles and more automatically. Entry point. So I guess is JExtract the tool that's going to be in the JVM? Come with the JVM? Where you can just point a header file at it and it'll just do its thing, create all this stuff for you? That's a question. Or no. Huh. Interesting. Interesting. Well, I mean, it's still preview. So JEP 454. Foreign function and memory API. Well, as it for small refinements. Okay. Huh. Memory segment data. Allocate. Okay. Well, that sounds pretty cool. I wonder if the LWJGL folks are going to be. Well, they use, if I'm not mistaken, they use Joggle under the covers. So I wonder, I guess they might have to wait for Joggle to update, which is the actual wrapper for OpenGL. So I wonder if the Joggle guys are going to do Project Panama stuff so that you don't need all this memory stack and stuff like that. That'd be interesting. That'll be interesting. Turning a status member comes up for creates a Vulkan object. The signals create a Vulkan object using some things we'll set up later. Create info struct. Select the constructor. VK application info calluk. Stack. Structure type application info. App short name VK API version. Okay, 1.1. Engine name. All right. Create a buffer object. Still have to run a calluk command to create the object for a singular item. Use calluk stack it for multiple. Rexes the number of items in the list. Okay. Defines its type. What information models from? Application name, just some text to identify the application uses instance. Okay. terminate string, application version, engine name, engine version, API version. The version of Vulkan API value should be highest value of the Vulkan version that this application should use and code it according to what is stated in the Vulkan specification. We're using 110. If you're using a newer version that's been ported to Java, use that number. Okay. I don't know what the API version 1.1. I guess we'll see if there's a newer version here or not. It's a layered API, mandatory lowest level. Vulkan Core is the mandatory lowest level layer. On top of that, there are additional layers that support useful things like validation and debugging. The driver assumes that you're using the API correctly and does not waste time performing validations. Fun. Error checking is minimal in the core layer. You must enable them through specific layers. Okay. Install Vulkan SDK for your platform. To use validation layers, you will need to install Vulkan SDK for your platform. Please consult the specific instructions. Okay. To enable validation layers on macOS after installing the Vulkan SDK, you'll need to configure LWJGL to use the Vulkan loader. Okay. Well, luckily nobody's writing games for Mac, so don't have to worry about that. Validation layers size. Support validation layers. Good warning, but continued execution. You have to install the Vulkan SDK. That seems weird, but okay. Like, what are you gonna do? I guess validation layers, I guess you just turn them off when you... While we're developing, it's good advice to turn them on to check that we're being compliant with the spec. This can be turned off when our application is ready for delivery. Okay, so the validation layers are really just to make sure that you're spec compliant. And it's really, that's why they're like, install these from the SDK, because I'm like, that would be very impractical to install on users' computers, and they're not expecting you to do that. They're expecting that to be just a developer thing. Okay. Number layers, hold layers properties. Total size. Next fragment shows how to retrieve these properties in their name and set them in a set. Okay. Which ones we want to activate? Google threading, LoonArg, Google unique objects. We first try to aim for the VK layer, Chronos validation, meta layer. A meta layer is basically a collection of layers registered under a single name. Oh, I see. Okay, this is... all this is just to do the validation layers, huh? Which are only really for development. Okay. Just, I mean, I get it, but at the same, in the same realm, like, you know, I guess they just, I don't know. You have all these different companies and they all have competing standards. And rather than just enforcing one standard, which would make the most sense, they just said, screw it, here's a validation layer, have fun. And so now it's on developers' shoulders to be like, am I compliant with the spec? Oh, let me run this let me put all this setup code in here that's only going to run on my developer box to figure out if I'm compliant with some random spec that apparently is different from one company to the next. That's this feels like one of those examples of software engineering, a social engineering problem, right? It's like, that's, if there's multiple competing specs, that's a social engineering problem, right? Like, you need to get everybody on the same page and have one spec that everyone agrees on. But instead they were like, yeah, we can software engineer our way around this. Here you go. And it's like, okay. Sure. Or maybe you just get them all in a room and just beat them silly until they all agree to something. I mean, it's harder and takes a lot longer, but it makes things a lot simpler. Just saying. Just saying. It means you don't have to do all this basically bullshit code that has no bearings on anything except when you're in development, and then you just have to, I guess, rip it out by the time you go to production. I mean, whatever. I mean, the way they have it set up is you just check to see if the layers are supported, and then it just won't run that code. But it's still, you're spending all that time writing code that is completely unnecessary if you just had a goddamn common spec. I mean, like what the hell, man? Like, what the frig? Get instance extensions. Extensions for the instance extensions. Vulkan's cross-platform. Links to windowing systems are handled through extensions. Okay. Enable validation not will need to add the extension used for debugging. I'll use the debug utils extension. Use that extension. Vulkan utils class get the type of OS. Okay. Okay. Create debug callback. Saying a callback so we can log the information reported. We've already enabled the debugging extension, but we need to create it. We log errors while creating and destroying the instance. Okay. Create debug callback. Back to severity. Create info. Instantiate the debug extension. Most Vulkan functions return an int value. So you check it against the VK success. Yeah, blah blah. Render. Use instance class in our render class in the constructor and cleanup methods. Okay. Validation should be... We have a new configuration variable to control if validation should be used or not. But didn't you just say earlier it didn't matter? Because you just would... None of the validation layers would be turned on when you make that call, so... That's weird. That's very strange. Yeah, that's really strange. That's what the code looks like. instance. Oh, they have, okay, they have bit masks for the different severities and stuff. Okay. Required layers, validation layers. Get supported validation layers. 0. Supports validation equals false. Come back to no validation. Yeah. I mean, you have the code there, so why did he have why do you have a property value for it? I guess to not even attempt it. It validates a number of validation layers. And I guess if not validate, then yeah, I don't see the point. You're doing the check anyway by having. I guess. Oh, I suppose. All right, I can see the idea. So the idea is that like if somebody does install the SDK on their machine, you want to make sure that that's turned off for production. So even if they do have it installed on there, it's off. And I guess even for debugging purposes, like if you're running it yourself, you want to turn validation off, doing performance testing and stuff. Okay, all right, sure, I get it. Still wouldn't put it in a property file though, but yeah, I sort of get it. Like I would put it as either a command line parameter or do it as, even better, do it as a JVM. Do it as a JVM parameter, because then you know no one's sending that to it. Source foundation. All right, so I can see now why they made an instance class, because there's so much bullshit in there. There's so much shit in here. So now I understand why they bothered to make a class for it, because like if I had this much crap that had to happen, then yeah, I would probably throw that in its own class, just because it's a lot of just absolute nonsense. Portability, required extensions, create debug, callback. Well, it does seem like this is important enough to do. Part of me just wants to skip it and say the hell with it, because I'm not that concerned about being spec compatible right now, but at the same time it seems like an important thing to have anyway. Validations and stuff, especially you know, if I go off the beaten path with things. All right, but I can see where they're going with that. So then what's I'm curious what chapter 3 is. Where's book contents? Chapter 3, here we go. Physical device. Progress of definition of Vulkan structures required to write into 3D scenes. Specifically, set up the physical device and a surface. Okay. Instance, physical device. Selecting and creating a physical device in a new class named physical device. We may have more than one Vulkan physical device in our host machine. In order to get the most appropriate one, the class provides a static method to do that selection and construct the associated object for us. This method named create physical device Iterates over all the available devices and picks the most suitable one. Okay. List of available physical devices. If there are no suitable devices, we just throw a runtime exception. Okay. Peg handle to the physical device. Sure. Support device selection. That the device, we need to check for two things. The device supports the graphics queue family. Okay. The device is capable of presenting images to a screen. Okay. You may have GPUs that may be used just for computing or that are not attached to any display. Yeah, okay. Need to be sure the device supports it. If the device fulfills both conditions, we can then check if its name matches the preferred device name, if this has been specified. If so, we already have our candidate and there's no need to continue, so we break the loop. Okay. Physical device. Methods, get physical devices. Okay. Enumerate physical devices, blah, blah, blah. Okay. 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 Nice. Colic and cleanup methods. Check the implementation of method, KHR swap chain extension. Okay. Right. Q family. Since the only pending method to present now is the one name, has graphics Q family. Talking about Vulkan queues. In Vulkan, any work is performed by submitting command buffers for specific queues. We do not command the GPU to immediately draw a specific shape. We submit a command to a queue which contains the instructions to render that shape. Commands in those queues are consumed and executed asynchronously. Devices have different types of queues, which are organized in families. Each queue family only accepts a specific set of command types. For example, we may have graphic commands used to render and compute commands. Each of these may require to be submitted to different types of queue. Okay, got it. And we have a physical device. We can start with the logical device. Okay. Logical device will store all the resources that we create alongside with their states. Create more than one logical device is another layer of abstraction over our GPU. Physical device. This is to manage resources. Sure. I mean, let's throw more abstractions at it. Why not? Device wraparound creation, some utility methods around it. Update our class diagram. Device starts like this. Physical device, Vulkan structure, logical device. Okay. Device constructor. Okay, buffer device queue create info structures which will hold the index of each queue family and its priority. Using a float buffer. Why is this? Don't just pass a single value. The reasons that when I create a logical device, all the queues that can be used are also pre-created. Okay. Device class and then surface. Okay. Display the rendering results. We've already developed the code for creating a window, but we still need to link it somehow with Vulkan. This is handled through the WSI Windows System Integration extensions. Okay. KHR surface, Win32 surface. We're going to create a surface. We'll create a new class. Read the GLFW library. If you recall, in the instance class, we already enabled the extensions required to integrate with the GLFW library. Card extensions had these names. New class name surface. Okay. GLFW create window surface. And there's the window handle and stuff. Okay. The real, how can I put this? To show you how stupid this is, if you're going to have, I don't see a point in having multiple surfaces on the same window if all it's really doing is just, if you're calling create window surface on there, I guess is what I'm getting at. I mean, I suppose if your window was like split into like 3 subsections, you could make them all surfaces, but why is my real question there. I mean, I suppose it might make some sort of sense. But even then, why? Like I feel like this right here, the create window surface could just go into the window method and call it a day. Like and if you want another surface, just have another window potentially, but then again, I'm not doing like I could see there being a reason for this. Like I could see there being a use case for this, but I don't know if there would be one for like a game or anything. It would be more like some kind of scientific visualization thing maybe, or something like that. I don't know. It just seems kind of silly. So command buffers to queues, right? Queue family and then queue. What the frig? Oh, I guess the queue family would be the type of queue, and then queue is just the actual workhorse. Queue is very simple. Get device queue. Logical device reference. Getter, get that handle, another getter for the queue family index, another useful method to wait for the queue to complete all its pending jobs. Okay. Does not provide a cleanup method. This is again due to the fact that queues were pre-created when the logical device was instantiated, so there's no need to remove them. When the logical device is cleaned up, their queues will also be destroyed. Okay. Let's find inner class. Name graphics queue. Create queues for submitting render tasks. I wonder why they did it as an inner class. I mean, obviously they want to extend queue, which is fine in and of itself, and maybe they just didn't want to have a separate file, which I can also agree with, given that queue is not very big. But does this have, this has its own constructor. So I ask again, why? Why not just... I don't know. Again, there's like... They're abstract happy. And I see there's a lot in OOP stuff where just people just get like... abstraction masturbation, basically. They just start going off making classes inside classes and classes that extend classes and interfaces, and then you look at them and you go, that's great, but then you don't actually use that interface for anything. Like, you use it once, or you use that parent class once, and it's like, why did you... Oh, well, there might be a time later on when we need like a different type of queue or stuff. Well, yeah, well, that time's not today, so why are we screwing around with that right now? Just make the one effing class, and if you need to refactor it later to make room for a second class, then refactor it later. And again, when you're, and this is the other thing, when you're teaching somebody something, right, and you're trying to write this book here to try to teach people how to do things, like, the less abstractions you make, the better. Or at least start out with less abstractions and then add abstractions as they come in, because then that makes it easier to follow why these things exist, instead of just abstractions for abstractions' fault, you know? So weird. So weird. But, I mean, on the other hand, it's good for me because it means that I'm not going to copy this code word for word. I'm going to write it myself and do it the way that I think it... do it the way I want to do it. So, there could be no misunderstanding about whether it's ultimately my code or not. All right, so we have a couple things. So I gotta tackle the Vulkan nerve pinch nonsense here with the validation layers and stuff, and I guess definitely put that into its own class because it looks like there's just a crap ton of stuff. And we'll have to see like what part of this I actually give a damn about and what part I don't give a damn about. Like anything doing with Mac OS, it's getting stripped out because I just don't give a damn. And we'll see what some of these other things are about. Doing debugging stuff and whatnot. But yeah, all right. Well, I mean, that's what I'm gonna have to do, but we're gonna do that next week because my brain is starting to shut down and it's getting a little bit late. But that said, all that said here, we've made our first baby steps into the Vulkan area. So there's that. Just have to make another... We're going to be writing a lot of code just to make the next small baby step, it seems like. But that's, you know, it is what it is. And there's a reason I put it into its own package, because it's kind of keep the fucktitude in its own corner, so to speak. So let's go and commit this, and I'll say initial look at Vulkan engine stuff. Alright. Get that out of there. Cool, that is out there. Also, I believe I had a... Yes, I do. The Pendabot has some things for me to bring in here. Check style, log back, classic. LWJGL, AWT, okay, and LWJGL goes from 334 to 335. Okay, well, let's do that. Let's merge these in. And bring that down. Oops. That is rebasing. Right, 4 to 335. How about this one? Are you still rebasing? Yep, rebase it. Rebase it again. There we go. Okay, let's go and bring those down. Cool, and let me make sure. Let me go over here and we'll make sure everything's still working in the other one. Oh, indeed. Here so. Yeah, okay. Good. Good, good, good. There we go. All right. That gets us where we need to be. Okay, my friends. That will do it for me for tonight, my friends. And actually, that'll do it for me for the weekend as well, because I'm taking this weekend off to... why is my cursor not leaving this screen? What is going on here? Did something break? Okay. Yeah, why is this not working now? Oh, there we go. I think I accidentally hit Control Shift Z and that stopped it. That put it on. That stopped it from moving to other windows. That was on me. All right. Yeah, that'll do it for tonight. And yeah, I'm taking this weekend off because it's my last weekend of vacation before I go back to work, and I got some stuff to do and whatnot. So just rolling with that. Let me see here. Let's see if I can get over to that screen. But yeah, thank you so much, everyone, for watching. I hope everyone has an excellent morning, afternoon, or evening, depending on what it is for you. And hope to see you back here again in the future for some more stuff, whatever happens to suit your fancy. And if you are over on, see this on the YouTubes, I would be very happy and very appreciative if you could like and or subscribe if you liked what you've seen here. That would be fantabulous. Anyway, thanks so much for watching, and I will see you next time, hopefully. I've completely undone my sign-offs here. But anyway, see you, bye.
Who are you, and how did you get in here?
I'm the locksmith. And I'm the locksmith.